Alright, so in this video we're going to solve the recurrence relation that we've got here on the screen, where n is greater than or equal to 0, and of course we've got these two initial conditions. So since this is homogeneous, sometimes it helps to get all the terms on the left side of the equal sign. And that just kind of helps us see that the recurrence relation is homogeneous. And then we can write our characteristic. So even though the subscripts look a little bit different, you've still got, right, you've got that this term a sub n plus 1 comes before a sub n plus 2, and same thing with this term. So you've got in the original recurrence relation, it's the n plus 2 term written in terms of the two previous terms. So it's the same idea as all the other recurrence relations that we've looked at. So this would correspond to the squared term in the characteristic, and this would be correspond to the t to the first power term, and then this last term corresponds to constant term in the characteristic, and so the characteristic is a quadratic, once again, that factors relatively easily. And so we have two distinct solutions to the characteristic. So using those two solutions, we can write our general solution. So some constant, whatever letter you want to use, times the first solution raised to the nth power, and make sure you use parentheses here since that number is negative. It needs to be negative 5 all to the n, plus some other constant times the other solution to the n. Now this is a little bit different. 1 to any power is going to be 1, so we can write that as just d. That makes the solution a little simpler in this case. And then we can find b and d with the initial conditions. So if I plug 0 in for n, that's going to be b minus 5 to the 0 would be just 1. So I'd have b plus d equal to 3. So there's one equation. And I can get a second equation if I plug 1 in for n. That would be b times minus 5 to the 1, which would just be b times minus 5 plus d, and that's got to be equal to 6. So there's my second equation. So I've got two equations, b plus d equal to 3, and then minus 5b plus d equal to 6. And if I want to eliminate one of these variables, probably the easiest is to eliminate the d. I just need this to be a negative. So I'm going to multiply through every term in the first equation by a negative 1 so that I can eliminate the d. And then I'm going to add the equations. So this would be minus 6b equal to 3, and that means b is 3 divided by negative 6, or negative 1/2. And then if I go back and substitute into, say, this first equation, negative 1/2 plus d equal to 3. So that means d is 3 plus 1/2, which is 7/2. So finally, if I know b and d, I can write that my general solution is b times minus 5 to the n, minus 5 all to the n, plus d, which is 7/2. And that gives us the specific solution to that recurrence relation with initial conditions.